Welcome to Programming Rainbow. So down here, we have this class that we're telling to update. Instead of SDL delay, we're saying FPS update. Okay, so what's happening here is we have this class. So we are using the steady clock duration and time points to keep track of the time and the time that has passed. Let me just show you here in the implementation. When we actually need to pause it for a calculated amount of time, we're using this thread sleep for. And again, this is a billionth of a second accuracy. This is down to nanoseconds. And we are going to kind of give it some leeway. That is 50 milliseconds leeway. So if one frame, we target it to sleep for so long and it sleeps a little too less or a little too much, it didn't actually hit the target we wanted it at, I'm going to give it 1/20th of a second play so it can actually say, hey, the next frame, I want it to delay a little more or a little less so we can get back on track. So it's going to have a little bit of leeway to kind of rubber band back and forth, but it's only 1/20th of a second. That's 50 milliseconds. So we are targeting in the nanosecond range, but I'm going to give it 50 milliseconds of wiggle room to allow it to try to catch up or to delay more if it needs to. Okay, so let me just show you this working. And this one actually has, separate from the actual setting the timing and creating this delta time, this actually has its own separate FPS counter. So even though it has logic to time the FPS, it separately has different logic that is actually counting frames. So I know what I'm targeting my FPS and I know what I'm really getting for FPS. The screen on my laptop only shows about 120 hertz. I'm only recording at 30 frames per second, but the game is going to be running. This FPS is going to tell me what my actual game is running at. So that rendering is happening whether the panel refreshes or not, or you see it in the video or not. The game is actually running at the screen. So whatever this show FPS returns is what my game is really actually running at. The logic is actually running at that speed. The render is being rendered at that speed. That is the real speed of the game. Okay, so I just want to show this off to you real quick. So I'm going to be compiling the video 10 instead of source. So I'm doing source directory video 10, and I'm just going to tell it to clean. So it does a clean build, do the release build, and run it. Okay, so now I have this added method where I can tell it to show the FPS, and I'll do it down here. So I'm going to press F, and it's going to show the FPS, and it says I'm getting 60 frames per second, like exactly 60. That's pretty good. What happens if we were to change it? So right here, I'm targeting 60. That's cool. What if we do it at 600? So that'll be 10 times faster. So I'm not going to do the clean this time. Since I'm still working the same code, I'm just going to tell it to build. So it's only going to build what it needs. But actually, I changed this header file, so it's going to rebuild everything. So can my system play this at 600 frames per second? Let's find out. Okay, I'm going to press F. And it says it's 600 FPS. Exactly. Like not even, that's pretty cool. So do you think it actually is playing at that? Let's try a little faster. Let's try 6,000. Or we could do anything. I could say 6,006. It doesn't really matter. So you may be thinking that this showing 60, let's show it here now, and it's showing 606, you may be thinking it's just telling me the number, whatever number I put in, it's telling me that. But I actually know my system can only hit about 14,000 FPS. And that's not what I'm recording. So I don't know if that's what I can get right now. So let's just move right up to 14,000. So it can bump between 14 and 15,000. But again, that's not when I'm recording. That's just when I'm doing my own thing. So let's just see if it does this. And you notice the movement of the game hasn't changed. And you might be thinking this is a trick. I'll slow it down as well. And you'll see that it kind of, if at like 10 FPS, it'll kind of skip across the screen, but it will be moving the correct speed. Okay, press an F. And you see this time even though we asked for 14,000, we're not getting 14,000. We're getting 11 or 12. So what's happened here is my system cannot give me the frames that I want. Let's press F. Sorry, I pressed F. And my fan's kicking on and all this stuff. But the game is still playing at the correct speed. Okay, so it doesn't matter if it gives me the frames I want or not. It's going to try to give me the frames I want, but my hardware is going to reach a limit where it just can't do it anymore. And here's another question. Using this 1/1000th of a second in this C++, how much better is this than using the milliseconds that SDL2 has built into it? All of this is based on the C++, the cron, and the thread delay, right? But let me just show you some other code. Okay, so this is my old Yellow Snow project for C, but it's attempting to do the same thing. And I did change it a little bit for this 50 milliseconds right here for the cap delay to bring it in line with the C++ code. But this is using just SDL get ticks, which is in milliseconds. And it's using down here SDL delay. Right here. Okay, so these are in milliseconds. And I'm also using a double to hold over the fractions that is past the millisecond range. Okay, so I'm not doing anything fancy here. I'm not doing any kind of nothing fancy whatsoever happening. The only thing I'm doing is the SDL get ticks and SDL delay. I'm doing something here to check rollover because it is a UN32 and it could roll over. So I'm checking rollover. Which we don't have to do in C++. But other than that, this is doing the same thing. So this is a million times less precise than C++. This is just using the generic built-in to SDL2. So how precise is this? We didn't get 14,000 frames. We got like 11 and 12,000 frames. So let's try 10,000 frames here, or maybe 11. So I don't think we're going to get 13 because I'm recording right now, but we should be able to get 11. And this is in C, not using any of that fancy stuff. And I am going to, because I'm using the source directory one. Okay, let's do F on it. Okay, I'm just going to let it settle down for a second here. And it looks like we are like within a couple, we're bang on. You know, we're only ever off by, it looks like 10 or something, 11. This is pretty good. Again, I'm recording right now, and this thing is telling me it's giving me 11,000 FPS. Oops, I turned off the frames instead of, and I still have my delta time movement, everything else. You know, I'm getting, I would say this is pretty stable at 11,000. Let's check the C++ if we can get stable 11,000 on it, or somewhere very close to stable. That looks like 11,000. This kind of shows that with this fancy ultra precision classes that they're doing with C++, we're getting nothing for it. Okay, so I would say that this is very steady. What's interesting is where can we break it? So this looks bang on. That is about as steady as we can get. Can we hold this steady at 12? There's going to be a point where my hardware just can't give me the frames I'm asking for. Okay, it looks like 12 is pretty steady too. Yeah, that looks really good. There's a little bit of fluctuation going on, but I would say this is very good. That's an outlier right there. I think when my fan kicks on, it starts to dip. You know, it was holding 12 really good, but I think this is not the problem of C++ or anything, but my hardware is just struggling. I'm right at the top peak of it. And let's try 13 real quick. This one should not be able to hold it. Oh, it's got 13. It's just, you know, like 300 here. Yeah, okay. Initially it's holding 13 and then it can. It's probably because of, you know, my system is using a bit of heat. So it's probably thermal throttling and whatnot. So I would say it's trying its best to hold 13, but it's no longer holding 13. Okay, let's see if C can do 13. So C++ did 12 strong. It was 13 where it started to kind of break down a bit. Okay, I'm just gonna let it chill out for a second. I mean, it looks really good. It's a little bit of wavering going on, but it's not like 400 or 500 like it was doing at the 13 mark. Okay, so let's try 1300. Also, my C code is not great here. Like I really want to rewrite this and re-record these videos for this C project because I'm not, it's not great for me. Like it's some things I don't like about it. So here we can see that it's not holding 1300. Okay. And this is not the fault of a C or C++. This is just my hardware. So we can see that right when we get up next to what the hardware can do, it's really, really trying to hold that number. And the C program is just not even using a C clock or anything. It's just using the SDL in milliseconds, which is 1,000th of a second. And I'm using a double to carry over. And the C++, I'm using a billionth of a second, a million times more precise. And it's giving me the same results. It's the same. The game is running at the same speed. I hope you learned something or enjoyed that and have a good day. I'll see you in the next one. Bye.